Okay. Next question is integral x square, x square cos x. What will happen if you have x square cos x? Again, algebraic, trigonometric. First into integral of second, fis, minus integral dfis. Dfis means derivative. If you want, you can just cut and paste here. Derivative of this, d by dx of this, and remaining cut and paste. That way also you can learn. But don't forget to put dx here. That became x square into integral of cos x is what?
Sin x.
Minus derivative of x square into sin x dx. That became x square sin x minus 2 integral x sin x. Now tell me, what should I do? Speak out. What should I do?
Again apply the same rule.
Again apply the same rule. First into second. So it become x square sin x minus 2 into first function as it is, integral of second, minus integral of, now cut and paste, derivative of first, integral of second, all into dx. So this became x square sin x minus 2 into x times integral of sin x is what? Minus cos.
Minus cos x.
Yeah, remember the minus. I'm asking every time the answer is so that you don't make a mistake. So x square sin x minus 2 times minus x cos x. Minus of minus plus integral of cos x sin x. So final answer is x square sin x plus 2x cos x minus 2 sin x plus c. I hope you understood. When square is there, first I started with x problem. Second, I started with x square problem. So x square problem, what will happen? You will have to do 2 times. That's all to remember. All of you agreed?
Sir,
Yes.
I have a doubt.
Yes, ask.
Sir, why there is plus c in the final answer?
Because if you differentiate x square, you get 2x. So what you can say? Integral of 2x dx is x square. Even if you differentiate x square plus any constant, still you will get 2x as the answer. So by definition, what you can say? Integral of 2x dx is x square plus any constant, generalization. So if I say integral of 2x dx is x square, what does it mean? If I differentiate x square, I'll get 2x as answer. But even if you differentiate x square plus any constant, you will get 2x as answer. So my generalization is integral of 2x dx is x square plus any constant. So this is applicable for every integration. That if you differentiate this function with any constant, you will get this as answer. That's why that constant term is there. Is it clear to you? Rumil?
Yes, sir.
Yeah, you have not listened to my first videos. That's why you're asking that question. Okay. Now let's go to the next question. Are you ready? Integral x cos square x dx. Now I am going to the first module. First module we learned how to integrate cos square, sin square, tan square, etc. All those problems I am going to put an x there. That's all. Now, how to do this problem? You need to always check whether the second function is integrable or not. If the second function is not integrable, we cannot apply the formula because our formula is what? Fis minus integral dfis. So if you cannot integrate the second function, your method will fail. So first you will have to convert this function to be integrable. So what is the method to integrate cos square x? One of you tell me. What is the method to integrate cos square x?
1 plus cos 2x by 2.
Shagun, superb. 1 plus cos 2x by 2. Now it is integrable. So what I wanted to show you is, if the second function is not integrable, make it integrable and then apply the formula. So 1 by 2 will be common for the whole question. Integral x dx, that is my first term, and then integral x cos 2x dx. Now here you will apply integration by parts, and here you can directly integrate. So my answer would be 1 by 2 into, I'm integrating this, so x square by 2. Integration, increase the power, 1 become 2. Derivative, decrease the power. Plus, now integration by parts. Which is the first function here? Which is the first function?
X.
X. And cos 2x is the second function. So let's speak out. First into, speak out one of you. Integral of?
Second function.
Second function. Integral cos 2x dx. So you should speak out like this. X into integral of cos 2x dx minus integral of derivative of x into integral of cos 2x dx whole into dx. Now we will write the answer. 1 by 2 times x square by 2 plus x into. Now tell me what is the integral of cos 2x? What is the integral of cos 2x?
Sin 2x by 2.
Sin 2x by 2 minus derivative of x 1 into sin 2x by 2 into dx. So that became 1 by 2 into x square by 2 plus x sin 2x by 2 minus half. Now integral of sin 2x again, that is minus cos 2x by 2. Those students who have attended integration before, they know why you are dividing by 2. Sin, if the answer turns to be C, there will be a minus with it. So my final answer 1 by 2 x square by 2 plus x sin 2x by 2 plus cos 2x by 4 plus C. This is my final answer. Is this clear? Okay. Recording. Okay. Yeah. So what we'll do, we have to recollect how to integrate sin x upon 1 plus cos x. Can anybody tell me how to integrate sin x upon 1 plus sin x? What is the technique of integrating this? Anybody?
Divide by cos.
Divide by cos, no. You need to rationalize it. Multiply with 1 minus sin x. So denominator became 1 plus sin x into 1 minus, so it became cos square x. Then you have to separate it. Sin x upon cos square x minus sin square x upon cos square x. Then this became tan x sec x minus tan square x. Then you will write this as tan x sec x as direct integral. Tan square x you have to write as sec square x minus 1. Now we are in a position to integrate. So sin x upon 1 plus sin x should be made in this format, then only integration can be done. So what you do first is convert sin x upon 1 plus sin x separately. So you will start with consider sin x upon 1 plus sin x. You can start writing. Rationalize it. Sin x into 1 minus sin x upon 1 plus sin x into 1 minus sin x. If you know this directly, you can write it. It's not necessary. Nobody will give you any marks for doing this rationalization. Okay, so you have to do it separately, or you may just mentally do it. Now you have to separate this sin x upon cos square x minus sin square upon cos square x. Then you'll write this as tan x sec x minus tan square x. Still it is not integrable. So tan x sec x minus sec square x minus 1. So you will replace this as tan x sec x minus sec square x plus 1. So this question you will modify it as integral x sec x tan x minus sec square x plus 1. Okay. Now you are in a position to integrate. Out of that, this two you can combine and this you can separately integrate. So that is up to you. You have written this. Can I remove this this part? Because
Yes, sir.
yeah, I'm removing this. Now I'll start integrating. So this is not important for integration part, this rationalization. You have to get that answer correct. So first, this whole thing is second. So first into integral of second. Minus integral of derivative of first into integral of second. Okay. So your answer became x into, directly now integrate each one. Sec x minus tan x plus x. Is fine with everybody? Minus. Now this part will be written again same way only, sec x minus tan x plus x. Understood that? Derivative of x became 1, so it is gone. And this integral you have already done here. The same thing you have to cut and paste. Now final answer. X into sec x minus tan x plus x minus, now integral of sec x. Who can give me integral of sec x? Nobody.
Log of sec x plus tan x.
Log of sec x plus tan x. Very good. Integral of tan x. Log sec x. Integral of x. X square by 2 plus c. Now what we'll do is log will combine and remaining this x square also you can combine. So I can write x times what all things? Sec x minus tan x plus x square minus log sec x plus tan x upon sec x minus of minus, minus of plus minus x square by 2. Now combine x square and minus x square by 2. So x into sec x minus tan x minus log of sec x plus tan x upon sec x. X square minus x square by 2 is plus x square by 2. Plus. So what I wanted to say in this particular problem is, whenever you come across second term not integrable, make it integrable and then apply the formula. That's all to understand in this. Is clear to everybody? Okay. Are you writing or completed writing?
Complete.
One method is, for example, I want to integrate log x. Remember, we do not have any direct formula to integrate log x. I will write this as integral log x into 1 dx. Now, 1 will be always taken as a second function. You don't have to look at that LIT rule. 1 should be always taken because this is so integrable. This is not integrable. So it has to be 1 should be taken as the second function. And this should be taken as first function. Now just say in your mind and tell me, how do you integrate first function as it is? Integral of second. So we have completed phys minus integral dphys. You have to write this in before and then start. Minus integral of derivative first, d by dx of log x, into integral of 1, whole into dx. Don't forget this whole into dx. This is what I might fear. You people forget this dx. So your answer became log x into x minus derivative of log x, 1 by x into x dx. So naturally they can be simplified and they turn to be a single term. So x log x, integral of 1 is x plus c. That's my answer. This is how you integrate log x. You don't have to remember this as a formula. Whenever you come across log of a function, then you write as log x into 1 and dx. So I call this method as one method. Now, what is the other function which you are integrating with one method? Sine inverse x, cos inverse x, tan inverse x. All the inverse trigonometric functions integral are also done by one method. So let's calculate this. Integral of sine inverse x into 1 dx. So first function, second function. I'll take one student to speak out. Okay, Darshan, your voice
Yes,
is very
sir.
good, so you can speak out. So tell me how to write what are the things to write? Just speak out.
Sine inverse x,
Sine inverse of x,
then integral of 1 dx,
1 dx,
then
then
minus integral
integral
uh, differentiation of
d
sine
by
inverse
dx,
x,
of sine inverse x. Yeah,
then integral 1 dx,
integral
whole
1 dx,
dx.
whole dx. Very good, very good, very good. This is important. So I'm writing the answers that sine inverse x, integral of 1, I can write x minus derivative sine inverse x, 1 upon root 1 minus x square into integral of 1 dx. Now my concern is whether you know how to integrate this term, x upon root 1 minus x square. Now comes your knowledge of integration over here. How do you integrate x upon root 1 minus x square?
X as sine. 1
Put
by
x
2
as
and
sine. Yes, Shagun, your method is better. What is the formula you're going to apply is integral f dash x upon root of x. We know integral f dash x upon f of x. What is the answer for this? If denominator's derivative is numerator, what will be the integral?
Log f
log of
x.
Log
fx.
of denominator. If there is a root here, it is 2 root of x. You have done this many times before. So you can see here 1 minus x square. And the derivative of 1 minus x square is minus 2x. So if I bring a minus 2 here, then the derivative, this became f dash x upon root of x. So my answer now became x into sine inverse x plus half. Now this is f dash x upon root of x. So 2 root of x plus c. And that's my answer. So your answer became x sine inverse x plus root 1 minus x square. Is it clear? So that is your final answer. Now try one problem of your own. Integral tan inverse x dx. So this will be integral tan inverse of x into 1 dx. Try yourself. Yeah. So did you start writing? This is the first one, the second. First function into integral of 1 minus integral of derivative of first, integral of second, all into dx. That became tan inverse x into x minus derivative of tan inverse x, 1 upon 1 plus x square into x dx. So it became x tan inverse x upon 1 plus x square. Derivative of denominator is 2x. So what I don't have is 2. So divide and multiply with the 2. So now I can write the answer as x tan inverse x minus half log of 1 plus x square. What did you apply here? Integral of f dash x upon f of x is log of modulus f of x. Okay, fine.
Yes, sir.
Okay. Now do yourself integral sec inverse x. So how should I write it? Sarang, come on, help me out. How should I write it?
So sec inverse x
Yeah,
integral 1 dx
do 1 dx.
minus
No, first you write 1. This first function, second function. Now you tell me the answers.
so sec inverse x integral 1 dx
Yes.
minus integral differentiation of sec inverse x into integral 1 dx the whole dx.
Whole dx. Very good. So I'll just fill up this.
X sec inverse x
Yeah. Now you tell me. Do you remember derivative of sec inverse x? 1 upon
1 upon root of
x
x
root of
modulus x root of x square minus 1
into
into x
x dx.
dx.
Now this x and this x will get cancelled. So it became x sec inverse x. Now, how do you integrate 1 upon root 1 minus x square? Anybody knows? Do you remember such a formula?
Log of x minus a upon.
Oh, very good. Log of x plus root of x square minus a square plus c. So this directly log of x plus root of x square minus 1. Yes, Agun, you have revised the formula. Good. Okay, I think you have understood this kind of form problem with the 1 dx. Now I am planning to teach you substitution method. Oh, you had finished it, no? How will I integrate sine root x dx? You remember bad angle? I told you about bad angle. Whenever
Yes,
the
sir.
angle is anything else than x, you must substitute that as t, provided the derivative is present. But the problem here is derivative is not present. So usual question is sine root x. They ask like this: tan root x. Then they ask tan inverse of root x. These are all common problems in your board exam, where the angle part is root x. So in such type of problem, what you must do is you put root x as t, no doubt about it. But derivative of root x is not present, so make x as a subject. Now differentiate. Dx is 2t dt. I hope you remember the substitution method. derivative of x. Actually, what is actually how it is done? You are differentiating with respect to t. So dx by dt is 2t. So what is dx? 2t dt. Why do you do this? Why you did this?
To
To
get the
remove substitution means change the variable. I must remove the dx. I must remove this root x. So dx is root x is going to be replaced by t, and dx is going to be replaced by 2t dt. So this function became now what? Now this function became integral sine t into 2t dt. So 2 can be removed outside, t into sine t dt. Why did I interchange the position? Algebraic, Liate. Algebraic is before trigonometric. So algebraic should be first and trigonometric should be second. So you can write the answer directly. 2 into first function into integral of second minus integral of derivative of first. Have you noticed that I changed the variable to t? Sine t dt whole into dt. So your answer became 2 times minus t cos t minus cos t dt. So 2 into minus t cos t plus integral of cos t sin t plus c. Now wherever t is there, replace it by root x. This is your answer. So substitution method, whatever the angle part comes, that should be put as t. If the derivative is not present, make x as a subject. So this idea should be applied only when derivative is not present. If derivative is present, you don't have to apply this idea. Okay. Understood this? Yes
Yes.
or no?
Yes, sir, got.
Yes, sir.
Yeah, try one more problem. Tan inverse root x. Tan inverse root x. But that remains almost same only. Root x as t, only the second part of integration is different. So root x equal to t. So x is t square. So dx is 2t dt. So this became tan inverse t into 2t dt. Liate. Which comes first, inverse or inverse trigonometric function and algebraic. Inverse comes first. So 2 tan inverse t into t dt. This first, the second. First into integral of second minus integral of derivative of first into integral of second. So that became 2 into tan inverse t into t square by 2 minus derivative of tan inverse t 1 upon 1 plus t square into t square by 2 dt. When you open the bracket, this 2 will get cancelled. So I'm opening the bracket. 1, 2 here, 1, 2 here, 1, 2 here. So I can write now t square into tan inverse t minus t square upon t square plus 1 into dt. Who is going to give me the method to integrate t square upon t square plus 1? Anybody? What do you notice the degree? degree of t square and first of all it's an algebraic function. Degree is
T
equal or
square
greater.
plus 1 minus 1.
Yes, division method. That is add 1 and subtract 1. In fact, you must express it as quotient plus remainder upon divisor. This format you have to express. To express it in that format, either you can divide or you can add 1 and subtract 1. So now I will write it over here. I'll change the color. So this became p square tan inverse t minus. When you separate this 1 upon t square plus 1. That became t square tan inverse t minus integral of 1 t, integral of this tan inverse t plus c. Now wherever t is there, replace it by root x. You can combine this both. So I'm going to write as t square plus 1 into tan inverse t minus t plus c. Is it okay? Now t square is x. So x plus 1 into tan inverse root x minus root x plus c. I'll write it this side. So my answer is, since I don't have space there, I'll write the answer. So final answer is x plus 1 into tan inverse root x minus root x plus c.